11c, actually D. Antidifferentiation of e to the power of kx, that should be D. Seems to be a trend every time we're changing something on this page. Okay, today we are learning about antidifferentiation of e to the power of kx. What you need to be able to do is integrate or antidifferentiate expressions of that particular form. Now you all know how to differentiate e to the power of kx. So if I have dy by dx of e to the power of kx, hopefully you could all know that the e to the kx part stays the same, and all we do is we multiply by the derivative. So hopefully you guessed it, all you have to do when you antidifferentiate is the opposite of that. So instead of timesing by k, what we are going to do is divide by the derivative of the inside. And of course, we've got our lovely plus c. So that's it. That's how you antidifferentiate. Let's go ahead and apply that to a couple of questions. Find the antiderivative of each of the following expressions. So for part A, this e to the negative 2x, as we said, stays the same. The 4 is just hanging out on the outside, and what we're going to do is we're going to divide by the derivative of the inside, which in this case is negative 2. Plus, so this all stays the same, and then we just divide by the derivative of the inside, which is 3, plus c. Simplify if you can, so 4 divided by 2 is just 2. That's just going to be a 2 on 3, plus c. And that's it for part A. Part B, same thing. So this is going to stay as it is. The derivative is a quarter, and then when you divide by a fraction, it flips. So that's going to be 4 minus, and then what we do is we add 1 to the power. So we're going to divide by 2, and 4 divided by 2 is just 2 squared. So plus c. Finally, for part C, I don't know if I'm going to fit it on this page. I'm just going to make a new one. So for part C, what we can see is we've got a function divided by another function. So we know we cannot integrate or antidifferentiate when this is the case. So what we must do is split this up. So we're going to split it up. That's e2x on e3x minus ex on e3x dx. So I've just split each term in the numerator over the denominator, and now I'm going to just cancel out. So I've got 2 at the top, which leaves me 1 at the bottom. I've got 1 at the top, which leaves me 2 at the bottom. And then I'm going to rewrite this, but all with a positive power. I'm just going to take them to the top. And then we antidifferentiate as normal. So this stays as it is. Divide by the derivative. In this case, that's negative 1, so that'll just become negative. This stays as it is. Divide by the derivative, which is negative 2. Negative times negative will be positive. Whoops. Positive. And it'll be dividing by 2, so we'll have a half at the front there. Plus c. So that's it for that. Example 12, given that dy by dx is equal to e to the power of 2x minus x, we've got y equals 5, x equals 0, find an expression for y. So I've got dy by dx, they want me to find y. The way to be able to get from the derivative to the original is by antidifferentiating, and then they also give me a value for y and x to be able to find c. So I'm going to start off y equals by antidifferentiating this expression. The e stays as it is, and we divide by the derivative, add 1 to the power, and divide by the derivative, plus c. We're now going to go ahead and substitute in our values of y is equal to 5 and x is equal to 0. So e to the power of 0 is just 1, so that becomes a half, and then a half times 0 is just 0, so we've got plus c. Take that half over to the other side, you get 9 on 2. So our final expression is going to be a half e2x minus a half x squared plus 9 on 2. And that's it. That's the end of 11D.